Okay, Assalamualaikum warahmatullahi wabarakatuh. So today we continue on chapter 4 Arithmetic Instruction. Okay, so last time we stopped at sub I. Okay, I hope you have tried all these examples. Okay, so we'll proceed on another instruction. So negate will not covered, extend will not covered, compare, CMPA, CMPI. So this all will not covered. Okay, so unsigned multiply, MULU. Okay, so what is unsigned multiply? Mulu. So multiplies two unsigned operand yielding an unsigned result. Okay, multiplier and multiplicand are both word operands, and result is long word operand. A register operand is the low order word. The upper word of the register is ignored. Okay, so what is the meaning of this statement? So so this one is unsigned. What is the meaning of unsigned? So unsigned is we consider all the value in of the source and destination is positive. So positive multiply with positive will get value positive. Okay, so multiply and multiplicand are both word operand, so it need to be conduct in such a way words times words, and then we'll get the value of long word. Okay, so this is the opcode, this is the operand. Okay, so let's see example. Okay, this one. Okay, mulu, this one is actually decimal number 3 uh, multiply with d1. Okay, so d1 is 3 is 3, in hexa also 3, so just take the word size, so the word size, so make it 4 bit. Okay, d1 is this one, a 00AO. Okay, so try to use your calculator. Okay, 3 times 00A0, because if the number at the front, if the 0 at the front of the one's number, if you don't want to put 000 also can. Okay, let's try to check whether it produce same result or not. Times 0000A0, so 1E0. Okay, but as what the definition, it need to be, the result will have to be in long word. Okay, so the rest you need to fill up with 0. Okay, so this one, as if you try to just multiply 3 to A0, also no problem, I think. Okay, 1E0. Okay, just you need to make it in 8 bit because it is a long word. The answer need to be in long word, store in D1. Okay, and then for D3, multiply with D2. Okay, D3 is you need to take this value 0003, and D2 is FF00. Okay, so 3 times FF00, so to get answer 2FD00 already 5 bit, so you need to add up at the MSB another 30 to make it long word. Okay, so the example C 7002 D2. So 7002 is this one, the value is at the position of this one. Okay, if you make it in the memory map, so this one is 7002. Okay, this one in 7003. Okay, so the 7002 is B000, B000, B000 times D2 FF00. D2 is FF00, FF00. So you get this one already 8-bit long word size, so just copy the result to D2 AF500000. Okay, so that's the example for the mul unsigned. Okay, multiply unsigned or mulu, the short name. Okay, next is sign multiply, mul s. So the s is denoted as sign, sign. Okay, so what is sign multiply? So the operation is multiply two sign, okay, two sign operand yielding a sign result. Multiplier and multiplicand are both word. Okay, same as mul. The multiplier and multiplicand need to be in the word size, but the result needs to be in long word operand. Okay, both of the word operands are in two complement form. Okay, two complement form. A register operand is the low order word. This one same. You need to only take the word size. The upper word of the register is equal. So what does this statement mean? Okay, so sign meaning that it is similar as what you have learned in basics math. Okay, okay, negative times negative, we will get positive value. Okay, positive times positive, we will get positive value. Negative multiply with positive, we will get negative value. Okay, positive times negative, we will get also negative value. Okay, so the second similar as the mul, the multiplier and multiplicand need to be in word format, so it needs to be 4 bit, 4 bit. Okay, time 4 bit, we get 8 bit. This is represent long word, this is represent word. Word times word, we get the long word. Okay, so the both the word operands are in two's complement form. So the two's complement form is the technique to represent negative number. Okay, so how to determine whether the word size of the data is negative or positive? Okay, for example, you have 1000 word size on the source or destination 100. So this one 1, the MSB is 1, so 1 in binary is 0001. So if the MSB is 0, so meaning it is positive number. Okay, positive number. Okay, if example the hexa value is FF00, so FF in binary is 1111. Okay, so if you get the MSB 1, so it is negative number. Okay, negative value. So then if this value multiply with this value, positive and negative, supposedly the answer also need to get the value negative. Okay, how to indicate whether it get a value negative or not? Check the MSB. Okay, check the value of the MSB whether it is 0 or 1. So let's move to example. Okay, so example A, mark sign 3 times or multiply with D1. Okay, 3 is 003. Okay, so it is already, it is obvious. If 0, no problem. 0 meaning it is positive value. Okay, positive number. Okay, D1 word size is D1 00A0. Also 0 is positive number. Okay, so just use your calculator to find the answer. 0003 times 00A0. So you get IE0. IE0, but the answer need to be in long words, so just fill up the MSB bit with 0. 00000. Okay, that is the answer in D1. Okay, then mul S D3 and D2. Okay, so D3, this one 0003, so no problem. Okay, so the MSB is positive. Okay, positive. But for D2, the value FF00. F in binary is 1111, so the MSB is 1, so it represents negative value. Okay, so if negative value is like sign extended rule, you need to fill up the rest with value of FFFF. Okay, so so I will not use this technique. I will use another technique. So this one actually will become, okay, D2. This one is D2. F is showing the negative number, so the upperwards size of this address content need to be replaced by F, 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 F00. Okay, D3 no problem because the MSB is 0, so it remain 3. Okay, so try to check using your calculator the answer. F F F F 6 F 1 2 3 4 5 6 0 0 times 3. So we get this answer, F F F F D00. Okay, D00. Okay, so next is 7002. 7002 is B000. Okay, this one. 7002 is B000. So the MSB is B. So B is 11. So 11 is in binary is 1 1 okay 1011. So it B in binary is 1011. Okay, so as you can see here, the MSB is 1, so meaning it is negative value. So negative value. So you need to fill up the uh, upper word size with F. Okay, so F, 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 B, 0, 0, 0. Okay, so D2, F, F, 0, 0. Okay, also F represent the negative value, so also need to be replaced with value of F, 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 0, 0. So just multiply this one. Okay, F, 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 B, 0, 0, 0 times F, F, 6F, 4, 5, 6, 0, 0. So you'll get the answer 50000. So the rest you just put a 0 in the MSB. Okay, so that it become the long word. Okay, that is so that's the example for the mul s. Okay, just you need to consider the word size of the source and destination data, and then check the MSB value whether it is has a 1 or 0 value. If convert to binary, okay, if it is produce 1, so the rest upper word size need to be replaced by F. Okay, if it's 0, just put or replace with upper word size with 0. Okay, so next is okay, this one example. Okay, the how to solve, but use a different method than what I have been showing to you just now. So if you can understand the solution in this slide, you can just proceed lah. Okay, but for me I use this method because it's much simpler. Okay, example. Okay, next is division, unsigned division. Okay, for unsigned division, it is almost the same as the multiplication. Okay, divide the unsigned operand L by the unsigned source word size and store the answer result in the destination 16R 16Q. So this one is 16-bit on the remainder and another 16-bit on the quotient. Okay, so uh, so what does this meaning? So the destination operand will have to be in the L size word divided by word. Okay, so we'll get this one is the quotient. This one quotient, quotient. Okay, so of course you will have the value here. Okay, so then you need to subtract. Okay, L minus X, so the remainder is what we call as R. Okay, so the format of the final answer will have to be x. For the answer must be in long word. Okay, so this one is the remainder, this one is the quotient. Okay, this is how to write the answer. Okay, so let's see that example. Okay, so for this one, d2 d2 divide by d1. So d2, you need to take all the long value. Okay, okay, 3. Okay, but since the value is 0, okay, at the upper bit of the numbers, hexa number, so actually you don't have to put it. Okay, okay, 3 d2 is 3. So remember, destination divide by source, not source divide by destination. Okay, d2 is 3 divided by d1. D1 only consider the word size, but since the upper bit is 0, so just take the 2 value. Okay, 2 2. So this one is the quotient, this one is the remainder. So how to write? So each quotient and remainder need to be in word size. So quotient is 1, so 0 0 0 1. Remainder also 1 1 0 0 0. Okay, this is the answer. Okay, next example B, d3 divided by 5. So d3 is you need to take all the value. Okay, long word 1 2, but the 3 in calculator you don't have to put it. Okay, because it is on the MSB, 0 is on MSB, it will not affect the answer. So 1 2 2 3 2, 1 2 2 3 2 divided by 5. Okay, so 5 is actually this is decimal number, but also in hexa also 5. Okay, 5 in decimal hexa same. Okay, so you can try using your calculator for this one. 1 2 2 3 2 divided by 5. So we get the answer uh, what is the answer just now? 3a 0a. So 3a 0a, 3a 0a. Okay, but in order to get this one, you need to this is simple division that you have learned from the primary school. 3a 0a times 5 first. 3a 0a answer times 5. You got 1 2 2 3 2. So 1 2 2 3 2. 1 2 2 3 2. So meaning that there is no remainder. This one Q, this one R. So the how to write the answer? So the answer is, so the remainder is 0 0 0 0 0. The quotient is 3a 0a. So this is the answer, 3a 0a. Okay, so I hope you understand, and I hope you try to calculate either using your calculator or in the easy CCAK software. Okay, this one you have to try. Okay, try it by yourself. It's around the same technique. Okay, so next is sign division. Okay, div s. So divide the sign, is similar with div u. The operand will have to be in the long word by the sign source word. Okay, and store the result in destination. Okay, 16 R MSB and 16 remainder and 16 quotient LSB. The sign of the remainder is the same as the sign of the dividend. All the involved data are seconds complement form. Okay, second complement meaning that you have to represent the negative value with F at the upper word size. Okay, let's see the example. Okay, D1, D2 divided by D1. D2 you need to take all the value because it need to be in long word size. So this one is D2, F, 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 D. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Divide by D1. Okay, D1 is word size 0, so it's a positive value. So positive value, so you just divide with 2. Okay, so F 7F 1 2 3 4 5 6 7 D divide by 2. So we get answer F. Okay, F. I think all F. 8-bit all F. Okay, 1 2 3 4 5 6 7 8. So then times 2, answer times 2. Okay, we'll get answer of F F F F F F F E. Okay, E, right, E. Okay, so this one need to be subtract. So F. Oh, okay, need to retype. F 7F 1 2 3 4 5 6 7 minus 1 2 3 4 5 6 7 E. So we get the answer also all F. Okay, also all F. 8F. So how to write the answer? So as you can see here, the result in destination, the remainder you have to take the MSB, the quotient take the LSB value 16-bit. So for the quotient, this one is quotient. So for quotient, this one is quotient, this one is remainder. For quotient, you take the LSB value. For the remainder, you take the MSB value. Okay, 16-bit remainder MSB, 16 LSB quotient. So the answer will become FFF. So quotient FFF, remainder also FFF. So you get this answer. Okay. So for this one, D3. Okay, D3. So So D3 is F, 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 E 789 divided by 5. So 5 in hexa also 5, but in binary it is 0. The MSB is 0. 0, 1, 0, 1. Okay, so this means positive value. But your operand is in hexa, so just divide by 5, because in decimal also 5, in hexa also 5. So use your calculator. F F F F E 789 divided by 5. So the answer is F F F, there's 5F B1C. 1, 2, 3, 4, 5 B1C. So this one multiply with 5, answer time 5, get that value. What is the value? F F F F F E78C. E78C. So minus this one. So F F F F E78C minus answer. Oh, sorry. F F F F E789 minus F F F F F F sorry, my babies. F F F E, just a bit more. 78C. Sorry wait F F F E 78C, you so you get F F F D. Okay, so the lower word is F F F D. Okay, F F F D. So the quotient you need to take this one, FB1C, put it in the quotient. Okay, for the remainder put an upper word FFFD. Okay, so you can try another example C and D. Okay, I think that's all for today. So we will continue on the part 3 arithmetic operation instruction. Okay, so today we have covered the mul u, mul s, diff u, and diff s. Okay, I think that's all for lecture chapter 4 part 2. So thank you very much.